So take a look at example number 4. Now, for example number 4, you have this f of x right here. It's square root of x minus 3 plus 1. Now, based on the reading of the graph, the minus 3 next to the x means we are moving to the, is it left or the right? We're moving to the right, 3 units to the right, and then plus 1 means 1 unit up. So so it's like so it's 1/2 of the parabola basically. So 3 units to the right, 1 unit up. So the graph would be like this. And again, you would practice the 1, 3, and 5 as your graph, but you just do it horizontally rather than vertically. So that's how we say square root is the inverse of x squared. And with that said, we can also go ahead and label the graph as f of x so that people would know that this is f of x. And we will go ahead and find out the inverse of f of x algebraically. So we will, again, do the most difficult step, which is to swap them. And then you just go ahead and get y by itself. So you take off things one at a time away from y. So you have the square root, you have the minus 3, you have the plus 1 to get rid of from y. So what's the first thing to get rid of? Not the square root yet. The 1, the plus 1. We will first get rid of the plus 1 because it's the farthest thing away from your y. One way to think about this is, it's winter time right now, or close to winter time. Let's just say you bundle up your few layers. You have a sweater, you have a jacket, and then you have a scarf. Like when you go indoor, you want to unload the clothing, right? What do you take off first? Scarf, then your jacket, then your sweater. So you first remove the plus 1, then you remove the square root by squaring it. And at last, you remove the minus 3 by adding the 3. So we say, oh yeah, so the inverse, it's going to be x minus 1 squared plus 3. So you would go ahead and make that graph. So you should know how to make this graph, do you? What form is this? This is the vertex form, right? So that means your vertex is at 1, 3. So let me go ahead and use purple. And your vertex is 1, 3. Of course it's 1, 3, because yesterday, what did we do? We swapped the coordinates, right? It was 3, 1, and now it is 1, 3. Now, it would not be the entire parabola because it would only be half of the parabola. It would only be this half of the parabola. And again, if you are wondering, like, how do you know? How do you know for sure? And remember this, that's the if they're inverses, and if we have both graphs on the same graphing area, they should look reflected across each other over y equals to x. Okay. So based on this graph right here, right now, what is the restriction? X must be greater than 1. Okay. So we say, yeah, so you have this inverse, which is x minus 1 squared plus 3, but make sure that you include a little appendix, little condition, and that is, yeah, it's just x being greater than 1. And if you want to further validate your restriction, then we say just go ahead and write down the domain and range for the original function. The domain is from 3 to infinity. The range is from 1 to infinity. And since we swap the x and y, the domain becomes the new range. Or you can look at the graph to tell the same thing. And again, this and this, they should agree with each other. The domain is from 1 to infinity, and that's why our condition, our little restriction here, it's x is bigger than 1. All right, now, let's answer the question. Is f of x a one-to-one function? Is the blue graph a one-to-one function? Does it pass the horizontal line test? Yes. Okay, we say yes. And then therefore, and if you look at the inverse, is the inverse a function? Yes. So so this is the highlight of the importance of the horizontal line test. If you see the function passing the horizontal line test, then the inverse would automatically be a function. Okay, we're just it's like doing the vertical line test a step ahead. Okay, so that's the key point of example number 4.